Hello, welcome back to BLENDERSUSHI live noding. In this episode, we're gonna do like this creation of the star. You might have seen these creations that I make using animation nodes. I can't remember, but this is a little bit more robust, and we can use noise and do all sort of funky stuff here. Yeah, so I decided to do it in SphereChalk, and then because in SphereChalk we can actually save it out as well, save out all this node tree, and then we can do quite a lot here with the noise, and then yeah, I guess I could just give you this node tree, but I think I found that building it from scratch is actually quite interesting. At some point, if you kind of forgot the concept, you can have a look, and then you might get more interesting idea. So the key here is to separate the circle. If you have a circle, make sure we double the vertices. So I have this multiply by 2, and then I use the list masking, separating the kind of like a even and odd number, and then from here on everything is pretty much pretty easy. I just keep adding stuff and layering stuff until I get this kind of design, but the idea is really pretty basic. So let's get started. I'll try to do this as fast as possible or as clear as possible, so it's better to do it slowly. SphereChalk star 001. We're gonna start with circle and viewer draw. We have this design. We're just gonna keep the edges for now. Okay, like I said, we're gonna use list masking. List mask out, and this our vertices data goes in there. First of all, we're gonna check the data that's out. Vertices, let's keep it small for now, 12. So currently at level list 1 we don't get the points that we need, looks like, so we need to level list 2. So now we can see from 12 vertices we can separate using the list masking, we can separate the even number and odd number vertices, so that's good, and that's exactly what we want. So by separating those, we can then join them back, and I believe we need to mix it, and if we do it right, we should get our star back. I mean our circle back. It's not yet a star, but you kind of get the idea. We need to get every other vertices. Okay, seems to be all good now. So between this and this, we're gonna do a lot. First of all, vector math MK2. Okay, this is a newer vector math. You can see this is the list is much handier now. If you want to multiply scalar, we have this floating value already, so that's exactly what we need. And by doing that, just by doing that, we can control the inner and the outer of the star. Cool. So that's the basic. The next thing we want to do, of course, we still have control over the radius and then the vertices here. We have to ensure that the number actually is always even number here in the vertices. We cannot have 11. 12 is good, 10, 8 is good. So we need to multiply by 2, x times 2, and this is to ensure this is the number that's the user is going to use, and then plug it into the number of vertices. So by doing it like this, we always have this star. The smallest one should be, I guess, should be 2. That's the minimum and the maximum. Don't want to be too crazy, maybe maximum 200, or yeah, just leave it like that. Okay, so we have our star already happening. Okay, what should we do next? We can add some more variations and layered of complexity here. Let's see, star enhance or star noise. You can use like sine wave, etc. here, but I found that noise is actually the good one to use. Noise, vector noise MK2 especially, and we're gonna use the scalar. The scalar is perfect for this because we can basically, with this guy, we can control the amount, how much we want to go in or go out. Okay, so if we just plug that in, and the vertices goes in there, so we have that kind of design already happening. Blender or standard Perlin. The noise, user can just choose the noise. We're gonna do the same with the other inner, and this is the inner, this is the outer, I think. So that should be good. If I'm not wrong, we also need to add a math here. This is gonna be plus. So this still control the outer radius, and we need a multiplier if I'm not wrong. I can't remember whether it should be the plus for or the plus and then the multiplier, or the other way around. Let's have a look. So that's the noise with the seed. Let me increase the number so we can see what's going on. Okay, so this vector noise is disturbing the outer, and this one controlling the inner. We actually want both to have kind of similar similar number for the inner and the outer. We need to control both of them. So the inner and the outer. It's actually doesn't matter which one, inner or outer. It's just they just need to have a enough difference so it still looks like a star. Vector noise. I think this should be the multiplier. Can't remember. I think what I remember is that we need to use vector math here and then do the scalar thing, multiply by scalar, so we can have that kind of ray of star. We're gonna do the same here down there as well. So yeah, this is exactly one of the classic example of procedural kind of thinking, computational, I guess, or parametric. We start with a circle, we end up with something completely different because of all this process. and especially with this star, we have the inner and the outer, and we have the similar pattern here. It's quite easy to just add in value and then change it and come up with something completely different. So this control the strength of the scale of the noise. This one control the radius. So we can actually zero it out. Actually, I'm actually doing it wrong. This should be multiplier, and then this should be the addition. So this is also something that's you will find out at some stage. Now, by doing it this way, we can control the radius still, and then also the scaling of the noise. We can zero out the noise still, and have the inner and the outer. Or actually, at this point, we can turn it back into full object. Instead of the edge, we can bake it. See, and we get this design star. We can also use this polygon. And okay, currently the viewer is not correct. We need to go to viewer draw option, turn on n-gons tessellations. That's really important. And then we know that we have this control, and we can control the noise, the strength of the noise, and what else? So this actually add or reduce the noise itself. Actually, the funny thing is we might actually need another multiplier here. Plug it in there. So here we can actually have another control. So multiply, add, multiply. This is kind of interesting. So a lot of control. So that bit's there. Just this one is controlling the noise. Actually, we can give it a different color. Probably like that color, and then copy, paste. That's really cool in Blender. You can just copy and paste color like that. So that's controlling the inner. If for the inner we don't want any noise, we just zero it out. We can still control the actual radius, and this is just another extra control. We have this. We can increase that. If we want to make the noise kind of animating, we can also use a vector math in here, and then just do an add. This guy is a vector, and we can use another vector in, and then we can kind of animate it in X or in Y or in the Z. It's nicer in the Z, I think. Math and frame. And it should be like the multiplier. It's gonna be like super fast. 0.02, 0.01. Still pretty fast. 0.006. Yeah, this kind of design is really nice. So that's for that. File, save as. Other than noise, we could actually use a sine wave in here. So suppose that, where was it? I think it's in the scalar here. If we control this using sine wave, we might get a different kind of design. We can give that a try. This is a single value math sine wave. Plug that in. starting to happen. Increase the strength. This thing has a noise going on, so with that thing off, actually I think the sign should come from another value, maybe range float. How many count? The count should be the same as the number of the vertices from this guy. So list length. So this bit I didn't plan at all. Just kind of trying to add it. This is 50. Okay, plug into that guy, and this goes into that guy. And we have like a sine wave happening. Sine wave goes -1 and 1. Maybe map range -1 and 1, and then this should be the radius. Starting to happen. We can control the minimum maximum. Okay, that's the effect of sine wave there. Maybe we can increase this number. Now you see we get a different kind of pattern, and if we change the start, that's looking really interesting. But the start and stop shouldn't change. Start at 1. This should kind of moving together in order to get that kind of effects. There must be like a formula to get this like a completely perfect looking like that, like whether you want to have more or less of this kind of star. Let's see, 60, 30, 20 give you that, 18, 30. Yeah, there must be a math behind it. I don't know. Maybe if we are using stop, it's gonna be a float value. So this, and then we have math here. The start. This is the start. This is gonna be the stop. 1 and 30. This is the start, this is the stop. We can adjust this offset, and we can animate this. So that's if you want to use the sine. Remember that we can always switch back to the noise. So the switch thing, if I believe Spreadshock has a switch node. So if we plug that in like that, we can control the state, whether you want the value coming from this guy, the sine, or from the noise. So that's see, it's starting to get more and more complex, and if you keep adding stuff, by the end you might have like 100 nodes like this, and you're starting to get confused. But you know, but at the very basic level, this is actually really simple. Remember, it's just a circle, and then you're kind of selecting and masking the even and odd number vertices. So this switch is important. I'm gonna give it a color. in order to keep this sane, we started to need to organize this. It's a range and then sine 1, 2, 3, 4, 5. This is just list length. Plug into that guy. So this is one idea. Give it oh, what is this shrink? Oh, that's for the bounding box. Sine wave, and we have this switch on off. We have this guy. That's the seed. That's the amount. See, so many attributes now in this. If we want to make it like really nice, we can turn everything into a monad. Monad is like a grouping in the spreadsheet. Ideally, the inside, the inner also get the same treatment like up here, but I think I'm gonna leave it right here. Yeah, I guess this is quite a good exercise. So again, we are using the sine wave, and here we are using the noise, and having control the scalar. There's a lot of concepts that we have learned before, and then we are applying it here. This is for the time, so we can plug that in. So the time, start again. Sine wave, we can control the speed. This control how many of the wave we need. So that makes a nice ray, and it's all animated. Yeah, I guess that's pretty nice. It's quite fun as well. This is definitely something that you need to understand. It's not like you need to memorize all this. But eventually, if you understand the concept and then you kind of have the idea in your head, you can recreate the recipe and then recreate this. Sometimes you actually using a totally different setup and getting the same result, but can be much simpler. Like I saw that many times with an example from Spreadsheet Developer. Sometimes I never thought that can be done that way, but it's actually possible. See, inside we have the noise and outside we don't have, and we can just pipe in any kind of data. Let's say these have the add. We can also have the add here and plug that in there, so we have the noise inside and then the star outside. And if that guys need to be that speed, the one at the bottom can be at a different speed, 0.06. So now that looks quite nice. Inner and outer noise, and we can control everything. Okay, so that's pretty much it for this live coding. If you have any more suggestion or feedbacks or question, let me know down below.